Good morning, everybody. So, as we know, in last class, we studied what is the significance of electronic configuration, and I have told you to learn atomic structures of first 18 elements, which is given in our textbook. Have you all practiced it? Again, I have told. So, first 18 elements, you have to practice atomic structures, and as well as now the tabular column, you can go with electronic configuration also. So, as we know, with the help of electronic configuration, we are having three significances which we studied in the last class. Can anybody tell me what is the first significance which we studied? So based upon the electronic configuration, we can estimate what, guys? Everybody. First one, we can estimate the size of the atom. Means based upon the number of cells, how big the atom is or how small the atom is, we can get a conclusion based upon the electronic configuration. So in this electronic configuration, we are arranging the electrons in KLMN shell like that. So who has given that KLMN cells? Anyone? Yes, please. Who given that way of representing electrons? Anybody? K cell, L cell, M cell, N cell, and also maximum number of electrons. So, how to calculate maximum number of electrons? Anybody? Yes, please. Suppose we all know that K shell, L shell, M, and N. So, I want to find maximum number of electrons. So, what is the formula we'll use? We all know. Please respond. N equals to 2, N equals to 3, and N equals to 4. What is the formula we'll use? Mitakshri?
2n square.
2n square, sir.
So if we use this formula, we can find the maximum number of electrons which we can fill in K shell, L shell, M shell, and as well as N shell. So that is what we studied. Next, so that is the first significance. We can find the size of atom. Next, the second one. What is the second one? Everybody?
So locate the position of the element.
Yes, to locate, we can locate the position of element. So what do you mean by position? Yes, please. What do you mean by position? It will come at the where? Periodic table. So periodic table, where it will come, guys? Periodic table, what is a periodic table? A proper arrangement of elements based upon their properties. So, based upon the properties, we will get where is the position of the element. So, totally how many groups and how many periods are there? Everybody?
18 groups, 7 elements.
18 groups and 7 periods.
18 groups and 18 groups and 7 periods, not elements. Understand? 7 periods. Danishkar, understand? I think Danishkar only speaking. Who spoke now? That is. Rohit, okay. So 7 periods we have and 18 groups we have. So based upon the electronic configuration, we can guess where the element is coming. Either it is coming in groups or it is, which group and which period, everything we can guess it based upon the electronic configuration. Same way, the last one. Last one, what we can say? Either it is a metal or metal or middle will get. What is that?
Metalloid.
Metalloid. So we can estimate maximum either the given element is a metallic in nature or non-metallic in nature, or in between that it will come up. For example, 2, 8, 4. 4 will come. So what is that? Valency. Suppose if I take silicon, so it is a what, guys? We used to call it as
Metalloid.
Metalloid. Okay. So that is what we have to remember. So once again, I'm repeating valence electrons. So as we know, valence cell. What do you mean by valence cell? All of you. What do you mean by valence cell? Yes, please. Outermost cell we used to call it as valence cell. So valence cell means, so it may be only one cell may be present. That cell itself is called as valence cell. Maybe 2 cells are present. that cell is called as valence cell. Maybe 3 cells are present and the last cell, wherever I am writing the last, you can notice it here. Here only one cell is present. So itself is the valence cell. But here what is the valence cell, everybody? What is the valence cell? L cell. And here what is the valence cell, everyone?
M shell.
That is what you have to remember it. So wherever whatever the atom you are doing, so wherever it is present, last cell, outermost cell, we is to call valence cell. Okay, so that is what you have to please make it right. Keep adding valence cell. Valence cell. That is what the definition is right now. Today's class, we are going to make that. Valence cell. Right. The outermost shell of an atom, the outermost shell of an atom, when the atom will become, guys, outermost shell, how many electrons should be there? Everyone, outermost shell, it must have 8 electrons to become stable in nature. But if it is has only one shell, that shell must be K shell, and that shell must be how many?
2 electrons.
That is what you have to remember it. So right now, definition, valence cell. The outermost shell of an atom is called the valence cell. Sorry, valence cell. Involved in the class, namesake, don't be for namesake. Now, let us take sodium. So all of you tell me what is a sodium valence cell? Sodium atomic number, fastly. By this time you should learn.
11.
Number 11. So please arrange in electronic configuration. Tell me K, L and M. So what is the electronic configuration, everyone? 2, 8, 1. So what is the valence cell? Fastly. Shruti?
1.
One cell.
Hurry, I am not asking valence electrons. I am asking valence cell. Valence cell.
M, sir.
What is the valence cell here?
M, sir.
That is what? So this is M. I am asking valence cell. So who is the valence cell? M. M cell is the valence cell. Are you clear? Now, next, oxygen. So oxygen I am taking. What is the oxygen atomic number? Fastly.
8, sir.
8. K and L. So arrange the electrons. 2, 6. Now, here what is the valence cell? What is cell?
Yes.
L cell. So L is valence cell. Is it okay, everyone? Please, that is what you have to remember. Next, valence electrons. Write it. Valence electrons. Now it is 1. Understand, Hari, what you are saying? Suppose if you take sodium, sodium is 1. Are you clear, everybody? Valence electrons. So what do you mean by valence electrons means? Keep it in mind. The total number of electrons present in valence cell. You understanding, Danishkar? Last cell, what is the electrons present? That is called as valence electrons. Do you clear, everybody? Now suppose sodium. Sodium, how many valence electrons? Everybody? Sodium, how many valence electrons? All of you, fastly. Sodium, how many valence electrons? 1. And oxygen, how many valence electrons?
6.
That is 1. So valence electrons means, right, the total number of electrons present in the valence cell. Present in the valence cell are called valence electrons. Is it okay, everyone? That is okay. Now, if I have taken sodium, so again, so example, so I am taking the sodium. So sodium, what is the valence electrons? Fastly, everybody. Sodium symbol is what? What is the sodium symbol?
Yes.
So 11. Okay. What is the electronic configuration? Fastly. Electronic configuration. Yes, please. Others also should say electronic configuration. K, L, M. 2, 8, 1. So, what is the valence electrons?
One, sir.
Valence electrons is 1. Valence electrons is equals to 1. Is it okay? Yes, Mr. Harish?
Yes, sir.
Yeah. That is what. Harish Eras? You also okay, good. It is. Today I will teach you something different, definitely. So make it fast. Makal to Johan and Harini. Aswin, understand Aswin? Noor? That is what you have to remember. Next, oxygen. If you have taken oxygen, tell me oxygen, how it will be? All of you. Oxygen, what is that? Atomic number. Harish? 8.
8.
Taken 8. So what is the electronic configuration? Electronic configuration, fastly. 8, so 2,
6.
so what is the valence electrons? Valence
6.
electron. Keep it in mind, it is valence electrons. Is it okay, everybody? Yes, please. That is
Yes,
what.
sir.
So valence electrons of oxygen is 6. Now, next term, what it will come is valency. That we will study after studying the atomic structure. Okay. So this valency is different from valence electrons. Are you clear, everybody? Valency is different from valence electrons. Keep in mind 3 words totally. One is valence cell, outermost shell. Valence electrons, total number of electrons in outermost shell. Next, valency will come, which we will study after studying the atomic structure of elements. Okay, so now all of you open your book. You'll be having a first 18 elements atomic structure. I want to know. Open that page number, everybody. So first 18. Later I will teach you, sir, how to draw more than 18. If the atomic number is more than 18, then normal electronic configuration you cannot draw. So that is what we will follow the separate process. That process only we will discuss now. So let us start with the first 20 elements. Let us take our today's whole class. Nothing will happen. So now all of you focus. After that only, after 18 only, I will teach you the remaining thing. So first everybody draw. But you have to draw very perfectly. So first element. What is the first element, everybody? Fastly. What is the first element? Hydrogen. So we all know hydrogen atomic number. What is the hydrogen atomic number? First atomic number, tell me. Atomic number symbol Z. Understand? So Z is equals to 1. So that represent the hydrogen atom. Everyone, how to represent the hydrogen atom? You remember that? Representing the atom. X indicating name of the element, and down. Down what will come, guys? Down what will come? Atomic number or mass number?
Atomic number, sir.
Atomic number. Atomic number symbol what? Z. And above, what will come? Mass number.
Mass.
Okay. So please remember that this is atomic number. Very important. Class 10th also, all the chapters depend on this only. That is what I am stressing. Atomic number. Next one is mass number. So class 10th, wherever we'll go, balancing equations, finding melting point, boiling point, finding molecular mass. Molecular mass, surely we have to find. Even carbons, compounds also. So please remember that. X indicating name of the element, Z subscript, atomic number, A superscript, mass number. So hydrogen, what is the symbol of hydrogen? Fastly, everybody. Hydrogen symbol is what? H. So atomic number. So it does not have basic hydrogen does not have any protons. So atomic number is also 1 and mass number is also 1. In exam, they will ask you, give an element or give an example whose atomic number and mass number is same. So who is that element? Fastly. Who is that?
Hydrogen.
Keep in mind, other than hydrogen, remaining all the elements that does not have same atomic number and the same mass number. Is it okay, everybody? Gokul, Kaushik, that is what you have to remember. Harish, Amar, Harish, Arun also not joined. That is what. So please remember that always only the element who is having atomic number and mass number is same. That is hydrogen. So how to draw? First, center, nucleus. So nucleus, how many protons? Positive charge is present in nucleus. So how many protons? Everybody. 1 proton, and it is having only 1 shell. So that how many electrons are revolving fastly? If 1 proton is there, we all know. Yeah, we know one statement. Can anybody tell me without my presence? Anybody fastly? In any atom, somebody is equal to somebody. Anybody? We know
Electron is equal to proton.
protons. Very good, Noor. Number of protons is always equals to whom, guys? Number of
Electron.
Electron.
Please keep it in mind that for any atom, number of protons is equals to number of electrons. But number of protons is not equals to, maybe not equals to what? Number of neutrons. Understanding? So maybe equal or may not equal. Yes or no, Harish? That is what you have to remember. So number of electrons also 1. So that electron is revolving here. That is what you have to remember. So this is the hydrogen atom structure. So what is the electronic configuration? Fastly. What is the electronic configuration? 1. You are right. You should not write 1. K1. Okay. Electronic configuration you must represent, or electronic arrangement. Electronic configuration K1. Is it okay, everybody? Yes, please. All of you?
Sir.
That is. Now, let us discuss the first 18 elements which is given in our book. So, this is the tabular column. Now, all of you should study this entire tabular column, including the electronic configuration, as well as valency also. So this valency anyhow possible today or else tomorrow surely will start. So by this time you will understand this last concept. Now, till electronic configuration, first 18 elements you all must know. You all must know without fail. Is it okay, everybody? Fully all the 18 elements till argon. So after argon, we will study now. So this is what atomic structures they have given. I think above the tabular column only. What is the page number? Book. Yes, here. Yes, very good. So this is what everything, first 18 elements they have given till. Starts with the hydrogen, ends with the argon. Okay, so let us write electronic configuration. This all the structures book definitely 10th class also it will useful, 9th class also definitely they will ask you minimum 2 mark question. So hydrogen electronic configuration, tell me what is that? K1. Helium electronic configuration, everybody, K2. Next lithium electronic configuration, fastly, KL. What will come? 2, 1. Next, beryllium electronic configuration. Fastly, guys. K.
K.
4. 2 and 2.
2, 2. Clear. Rend electron. See here. 2 and here 2. That is what you have to remember. Next, here. Boron. Beryllium it is. Boron, tell me. Boron, how it will come?
2,3, sir.
2,3.
Next, carbon.
2,4.
2,
2, 4. Others also should say. Next, nitrogen.
2,
2,5, sir.
5. Oxygen. Just now we have studied.
6.
6.
All of you should do that. That is what? One by one you have to. Very good, Nimish. At least say next fluorine. This is called as what? Fluorine. Fluorine, tell me.
2,7.
7.
2, 7.
2,7. Next neon.
2,8.
2,8, sir.
Have you noticed it? 8 electrons came in valence cell. So it is called as something. Anybody? 8 electrons in valence cell. So have you noticed it? In this all the things, lithium to neon. What is the valence cell? I want to know. Valence cell.
Yeah.
Lithium to neon. What is the valence cell? Everybody.
L
L
cell, sir.
L cell. And lithium, what is the valence electrons? Valence electrons.
1, sir.
1. Beryllium, valence electrons. 2.
2.
Valence electrons. 3. Carbon, valence electrons. 4.
4.
Nitrogen, valence electrons. 5. Oxygen, valence electrons. 6. Fluorine, valence electrons. 7. Yeah. Neon, valence electrons. 8. So whenever you get 8 in valence cell, I told you that is called as which gas? Yes,
Inert gas.
inert
Noble gas.
or we can say inert gas. Inert gas or we can say
Helium also,
noble
sir.
gas. Understanding? Of course, helium also. Helium also noble gas. Why? Why? Everybody, Kaushik, it has only one shell. That shell itself is a what? It has
Valence shell.
one shell. That shell itself is a what?
Valence shell.
K shell, and it has valence shell. And maximum how many electrons we can put?
2, sir.
2. That's why helium also considered as a what? No. Clear? That is what you have to remember. Other than helium, remaining all they have 8 electrons. Next, sodium. Sodium fastly, solunga, fastly everybody. Sodium what?
2,8,1.
Alm 2,8,1. Magnesium K
2,8.
2,8,2. Aluminium KL 2,8,3. Silicon KLM 2,8, fastly. Phosphorus KLM 2,8,5. Sulfur KLM 2,8, fastly. Sulfur
6.
2,8,6. Chlorine, we all know. What is the atomic number of chlorine? Fastly. Atomic
17, sir.
17. Clear? So 2,8,7. Last, argon. Argon, everyone? Yes, please.
2,8,8.
KLM 2,8,8. Now tell me here, what is the valence cell? From sodium to argon. From sodium to argon. Valence cell. Firstly,
M6, sir.
yes. And who is the inert gas here? Tejaswini, Shruti, please speak. Who is the inert gas in this? Sodium and argon. Inert gas. Argon.
Argon, sir. Argon, sir.
Yeah, why argon? Because argon having
Electrons.
because argon having 8 electrons in its which cell? All of you. Valence cell.
Valence shell.
That is what we can say. It is inert gas. Are you clear? Yes, please.
Yes, sir.
Now, sir, till 18, it is easy to write. So you can go back to the screen. So let us see. Till 18, any element we can write directly electronic configuration. So let us write potassium. So we all know, no, sorry, not potassium. So we'll go with the argon. So what is argon? Argon atomic number, fastly. Just now we studied. 18. Symbol of argon, AR. A call to Nimish, Johan, Harini and Arun Kailash. Argon. So argon, if you have taken, argon atomic number is 18 and mass number is how much, Amma? Mass number, 40. What is the mass number? All of you?
40. Please remember that. You all should know this. Argon 40. So now electronic configuration. So what is electronic configuration? Tell me. First, K shell. K shell, 2 we can fill. 18 minus 2, 16. So 2 will come. Next, K shell, L shell. L shell, 16 minus 8, 8. So L shell also 8. Now M shell. M shell also 8. So that is what electronic configuration of argon. Is it right or wrong? All of you? Yes, please.
Yes, sir.
Yeah. Now, above this, we cannot follow the general method. So we have to go with some other method. So that is what we will discuss now. So for example, if you go with the potassium and calcium, 19. So what is the potassium symbol? Fastly tell me, not phosphorus. Potassium.
K.
Yes.
K.
Potassium symbol is K. Atomic number is 19. Mass number is 39. Mass number is what? 39. Are you clear? So you can see that atomic number is 19. Means what is the number of protons? All of you. Number of protons, how many? 19. Number of electrons also, how many? Shruti? 19. Now, can you find number of number of neutrons? How many? Don't say number of neutrons also 19. It's very bad.
0.
20.
0.
20.
How, sir? Which is the formula? We all know. Atomic mass number is equals to, what is the formula? Number of protons plus number of
Neutrons.
neutrons. Yes or no? So mass number is 39, number of protons is 19, plus we want number of neutrons. So number of neutrons is equals to 13 minus 19, which is equals to how much?
20, sir.
20. Clear? Yes or no, everybody? I have taught you or not? This one?
Yes,
Yes,
sir.
sir.
Yes? Akilan, understood? Kaushik? Hariseras? That is what. So you have to remember that. Now, potassium, electronic configuration, tell me, all of you, electronic configuration. Yes, please. K shell, 2. Yes, L shell, 8.
8.
M shell. M shell actually what? M shell
N,
what
sir.
capacity? Original capacity. M shell original
8, sir.
capacity 1. Capacity. M shell original
8.
capacity. Harish.
8.
Square, which is equal to 2 into 3 square, which is equals to 2 into 3 square 9. How much?
18.
So now 19 minus 2, how much it is? 17. 17 minus 8, how much it is? All of you.
9.
So can I write 9 here? Is it?
Yes, sir.
No, wrong. That is what from 19 we cannot follow normal method. So do you all know that electronic configuration of potassium is 2, 8, 8, 1. What is 2,
Yes, sir.
8, 8, 1. Sir, how, sir? I will teach you. I will teach you. That is what we are going to do in our today's class. So remember that. What is the electronic configuration of potassium? All of you? 2, 8,
8, 8,
1. Next, same way, calcium. See, till 18, no problem. After 18, normal method you cannot follow. Clear? So that is what you have to remember. So, calcium. What is the calcium atomic number? First symbol, tell me first calcium symbol. Fastly, everybody. Ca. Atomic number is 20.
20.
Mass number is 40. Okay. Mass number is 40. You have to learn it. So electronic configuration, tell me everybody fastly. K, L, M and N also will come. So what is the electronic configuration? You know, 2, 8,
8, 2,
2. So like this will come. Sir, how, sir? Because M shell, what is the maximum capacity? Maximum capacity is how much, guys? Maximum capacity
18, sir.
18. Why can't we write 10? M is equals to 10. Why can't we write? We cannot write because After atomic, remember, after atomic number is 18, once Z is greater than 18, we cannot follow normal electronic configuration. Understand, Mitakshri? Abhirami? Yes? So if Z is
Sir.
more than 18, then we will follow new method of electron arrangement. That is what we used to call as off-bow principle. What we used to call? All of you? Off-bow principle. Please write. Shall we start? Write it. AUF BAU. AUF BAU. Off-bow principle. So from 18 after, we have to use which rule? Till 18, okay. After 18, we have to use off-bow principle. Is it okay, everybody?
Yes, sir.
Yes, that is what you have to remember. Okay. Now, till now, whatever the elements are present, till now, what is the known elements to the humans? Fastly, anybody? Total known elements till now. Total,
180.
yeah, total known elements to the human beings up till today is 118. So all the 118 elements till now we can finish the electronic configuration only K, L and M and N. Is it okay? More than this is not required. Understand, Harish? Harish, more than this is not required. So within these four cells, we can arrange all the electrons. Okay. So that is what we will make off-bow principle. So first, right, what do you mean by off-bow principle? Right. The off-bow principle, anyone having doubt, you can ask me. The off-bow principle, Akilan, understand, Akilan? Gokul, dictates the manner in which electrons are filled. Electrons are filled in the atomic orbitals of an atom in its state. Okay, so that is what our bow principle. Is it okay, everybody? I want a response from you all people. Yes, please.
Yes, sir.
Yeah. Now, all of you remember. Now let us go back to the Bohr's model. We all know Bohr's model. So Bohr's model, what it will say is, center who will be there? Center who will be there? Nucleus. And by that, it is having orbits. Orbits also called as some other name. Anybody can tell me what is that orbits called as?
Energy level.
Energy levels. Also, we can call one more name.
Shell.
Remember, orbits are energy levels or cells. So totally, how many cells I told you? K, L, M, and N. Okay. Now that is enough for us. That is enough for us to fill all the 118 electrons of till today's. Okay. Now K shell. What is the number given for the K shell? N is equals to 1. Which shell it is? K. N is equals to 2. Which shell it is? L. N is equals to 3. Which shell it is? All of you. M. N is equals to 4. Which shell it is? N. All of you remember, like now onwards, we are going to write in the form of off-bow principle. How means we will arrange just till now. See, we are representing in the form of direct electrons. Yes or no? Hydrogen 1 electron, helium 2 electrons, like this. Yes or no, Harish? Lithium 3 electrons. So 2 here and 1 is outside. Yes or no? Like this we are arranging. Yes or no, Mitakshri? Yes. Now onwards we arrange in the form of bus. Okay. So let us imagine like our normal bus. So what is that bus means? So if you'll notice it here, every shell having a different kind of buses, like big bus, small bus, and all. So just for our purpose only we are making. So what is that buses means? So we can make in the form of like, all of you remember, if you take K shell, K equals to what is the number given? K shell, all of you. It has a bus number. It has a bus having only one seat. That bus seat called as 1s. What is the bus, everybody? What is the bus? What is the bus name? 1s. Understanding? So maximum number of electrons. Maximum electrons we can fill in S bus. S bus, okay, is 2. How many electrons we can fill, guys? Maximum in S bus. S bus, how many? All of you, 2. Clear? Next, if I go to the K shell, K over L shell having, remember, S bus is having, and also it is having P bus. It is having what bus, everybody? It is having what bus? S bus and having P bus. Understand, Mithakshri? Yes?
Yes, sir.
S bus, maximum how many electrons we can fill? I already told you. S bus.
2 electrons.
Understand? It has only one seat. Like our general language I am talking. One seat, how many members can sit? 2 members can sit. One seat, how many members can sit? Everybody?
2 members.
Can sit. Now, P bus if you will come, P bus having totally 3 seats. So totally how many can sit? Maximum how many can sit? Fastly. Maximum electrons. How many, guys? Open your mouth. Maximum how many can sit? Each seat 2 members, guys. So how many can sit?
6.
6 members can sit. Are you clear? No answer. Do you understand what I'm saying?
Yes, sir.
Yes, that is what to remember it. So now, next, go with the next one. Third one, KLM. M shell having 3 buses. One bus is S bus, second bus is P bus, and last one is D bus. What bus it is? D bus. Now, S bus, how many seat? I told you, S bus having only one seat. P bus having how many seats? 3 seats. Okay. And D bus having 5 seats. So totally how many can sit? 1, 2, 3, 4, and 5. Totally how many members can sit? Maximum. Fastly, ma'am. Maximum 10 members can sit. Understand, everybody? Like normal language, I am talking about normal language. Are you clear? Now, can you tell me what is the bus name? See here. If the bus is in first shell, I am taking 1s. Now, if the bus is in L shell, can you tell me what is the name? S bus name? What is his name? 2s. Understanding? And this P bus is in L shell. So what is this bus name? Firstly,
1P.
Hari, 2P. Understand, Hari? 1P will never present because 1 is not present. P is not present in K shell. So 1P will never exist. Understand, Hari?
Yes, sir.
So which shell it is present? That is what you have to remember. Now M